This video is over exponents in scientific notation. So we're now going to transition to scientific notation and what it is. So scientific notation takes the form a times 10 to the r power. The a in the scientific notation has to be between 1 and 10. A can be 1, but it cannot be 10. So it has to be anything pretty much less than or equal to 10, but greater than 1. The r, or the exponent in scientific notation, is how many times the a is being multiplied by 10. If that r is a positive value, then we know the number will be very large. And if r is a negative value, then we know that number is going to be small, so we have a decimal. So what we're going to start off doing is we want to represent each of the following numbers in scientific notation. So we know a red blood cell is about 0.000008 meters long. Now it's very hard to read that number because of the multiple zeros. So what they do is they write this number in scientific notation so it's easier to read. So remember, scientific notation, we always want a times 10 in there. And we want an exponent on the 10, and we want a number before the 10. So let's determine the number that we're going to put in before we put the 10. So remember, the number has to be between 1 and 10, not including 10. So if I look at this, I want an actual number there. I don't want any zeros. So the number between 1 and 10 would have to be 8. I can't put 0.8 because, again, that's not between 1 and 10. I can't put 80, again, not between 1 and 10. So it has to be 8. Because this is a decimal or a small number, I know my exponents on my 10. Ooh, what did I just do? Oops, there we go. I know my exponent on my 10 is going to be a negative value. So what we're going to do is we're going to move my decimal until I get the decimal after the 8. Remember, there's technically a decimal after 8, it's just not written. So I'm going to count how many times it takes me to move this decimal till I get it till after the 8. So I'm just going to move it. There's 1 and 2, 3, 4, 5, 6. So I know I had to move the decimal 6 times before I got to the place where the 8 was after, or the decimal was after the 8. So because I moved it 6 times, I'm going to put an exponent of 6. But really remember that exponent is -6 because it's a decimal, it's an extremely small value. So really we are able to say a red blood cell is about 8 times 10 to the -6 meters long, which is a lot easier than saying 0.000008 meters long. All right, so let's try another example where we're expressing a value in scientific notation. So again, it's a proven fact that we know the temperature of the core of the sun is about 27 million degrees Fahrenheit. And when you look at this number, if you look at it really quickly, you might not realize it's 27 million. You might say, oh, 27,000, 27 trillion by accident, not paying close attention. So we're going to write this number in scientific notation so it's easier to read. So scientific notation, we know we want our times 10 in there. Again, we want a value before the times 10, and we want an exponent on the 10. So let's determine the value before the times 10. So we want a number that's represented in my given number between 1 and 10, but again, not including 10. So I have a 2 and a 7. If I put 27, again, that value is not between 1 and 10, so that wouldn't work okay. If I put 0.27, that's not going to be okay because it's not between 1 and 10. So if I put a decimal between the 2 and the 7, I get a value between 1 and 10. So when we look at this number, we hopefully notice it's a large number. It's not a decimal, so I know my exponents on my 10 will be a positive. So what I want to do is I want to take my decimal, which technically is after that last 0, and count how many times I have to move it, so that way it's between the 2 and the 7. So again, just count it out. 1, 2, 3, 4, 5, 6, 7. 7 times I have to move it before it's between the 2 and the 7. So my exponent on the 10 will be a 7. And remember, it's a positive 7 because this is a large number. So I'm able to say the temperature of the core of the sun is about 2.7 times 10 to the 7th degrees Fahrenheit.